At Dyson, we've brought 1,000 of the world's best engineering minds together to imagine, create and build the best machines available. Many other vacuum manufacturers talk about how well their machines clean carpets, but in fact, they leave a lot of dirt and dust behind in the home. Our intention with this vacuum was to engineer a machine that had twice the suction of any other, a machine that would clean better across all floor types, carpets and hard floors. To get good dust pickup across all floor types, there are several important factors. There's the brush bar that spins, which loosens and agitates the dirt, and there's the suction at the clean head, pulling the dust away. We've got a motor here that's delivering 25% more power to this newly configured brush bar, and that basically drives all that power deeper into the carpet pile, pulling allergens and dirt out, which other vacuums leave behind. We've also got a very high efficiency separation system, and if we look here, there are 12 cyclones which spin the air very, very quickly and create incredible forces to capture the tiniest particles. If we look at this machine, it doesn't actually have any secondary stage high-speed cyclonic separation, and as a consequence, it has to rely heavily on this porous filter to trap that fine dust. The problem with many machines is the clean heads are set at a fixed height above the floor surface. They can't adjust between different floor types. What this means is they have a large gap around the perimeter of the clean head. If we put a light behind, you can just see how pronounced that gap is. That is going to be wasting a huge amount of suction energy, especially on hard floors. So on our machine, we've addressed this problem with a self-adjusting sole plate that seals in the suction. It enables the machine to drive seamlessly from hard floor to carpets and maintain that very tight seal all the way around on crevices. It enables it to drive over debris, and it also enables the brush bar to drive deeper into the carpet and still have very, very easy push force. Looking closer, if I put the clean head onto carpet, you can see that the bellows around the floating sole plate are compressed. But when I put it onto a hard floor surface, it adjusts and you can see the bellows have expanded, and that again is maintaining a very tight suction seal around the perimeter. So we've strapped this machine down to what we call an AirWatts box, and that measures the suction at the clean head. Okay, so if I turn the machine on, you can see straight away we're getting very, very high suction. If we compare ours to this machine, we can see here that there's significantly less suction at the clean head. This board has had a series of grooves cut in it, which we filled with household salt. It replicates the kind of gaps you find in your hard flooring around the home where dust accumulates. It's a really good measure of vacuum cleaner performance. It's just taken the top off it. If this was a floor in your home, this machine would have left all this dust and dirt behind in those crevices, whilst the Dyson has pulled almost all the dirt from these crevices. As you can see, there's hardly anything left. This is one of the first early prototypes of ball technology, which completely transformed the way a vacuum cleaner manoeuvres. Fixed wheel vacuum cleaners are fine for going in a straight line, but your house is full of obstacles, and the ball enables you to navigate around all the obstacles very effectively and efficiently. Inventing new ways to manoeuvre meant we also had to invent new ways to test that manoeuvrability, and this robot simulates 10 years of everyday use. Just by turning my wrist, you can see the difference in manoeuvrability between these machines. Our machine offers a huge range of manoeuvrability, not even having to move my body to get right into the corner. Let's try this machine. Again, this one can't achieve the same range of motion. Actually, the head is starting to lift up a bit there, so I have to walk round to get into that corner. We build our machines to last. We want them to be robust and durable, so we put them through a huge amount of testing that will recreate the rigours of 10 years of home use. This is an example of one of the many tests we put our vacuum cleaners through. It drops the machine and tests out the strength of the handle and the catch interface. This is the pendulum hammer rig that we use to test the robustness and durability of our machines. See that it's just cracked. Now our machines are made of polycarbonate, the same material used in riot shields. Ready? No damage at all, just bounced straight off. Not only does this machine have twice the suction, but it's incredibly strong and durable.